Right, we're back to the second video for Food Chemistry Lecture L02a. This is a bit outside the scope of the module, but it's certainly of general interest. The description of photons engaging with colour molecules we've used is reasonable and it provides a good basis for understanding what has happened. However, in some cases the interaction is proven to be very much more complex, including quantum physics. The most important example of this is in photosynthesis, one of the most important biological reactions, allowing plants to fix carbon from carbon dioxide in the air, produce sugars and producing oxygen as a byproduct, without which animals would not have evolved and we wouldn't be having this conversation. This is now thought to involve complex quantum mechanical interactions. Now, quantum mechanics is the branch of physics relating to the very small. This has often involved some very remarkable concepts, such as particles existing simultaneously as both particles and waves. If you're interested, see this article for a review of the current understanding of how photons engage in photosynthesis. It's a good link. It's not fantastically technical, so we should all be able to understand it. I could, so I'm sure you can. Okay, plant colours. As I mentioned, it's not just about us. And here's a famous example from childhood. Plants evolve colour for their own evolutionary benefits. Small children in the UK may think that buttercup exist to tell whether a person likes butter based on a reflection of light on the underside of their chins. But the real reason, of course, is to attract pollinating insects. And there's a paper here which actually reviews this concept, and it's well worth having a look at. These are some extracts from the paper. The diffuse yellow colour, which we can observe under the chin, seems to provide a general guide for pollinators. The incident, I'm going to have to correct that word. The incident light passes through the epidermis outer layer of the flower, where light towards the blue end of the spectrum is absorbed, with the yellow component being reflected back in a diffuse way and giving the flower its overall colour. However, part of the light is strongly reflected back as dots that are only visible in the UV region. We can't see this, but many pollinating insects can. Again, this arises from interaction with many carotenoid pigments, so that's a sort of pollinating insect's view of it. Yeah, and there's just the second image. So for more on the chin illumination game and related papers, related issues, see the paper. Many animals see a slightly different spectrum of light than humans do, including bees, which can see well in the UV region. UVAs from 315 to 400 nanometers. Compare that to the wavelength of visible light we saw a bit earlier on. The Silurian bat is a fruit eater, so potentially a pollinator of local species. Again, it can see further in the UV than we can, so it may well be picking up signals we can't see from flowering plants in its environs. Right, okay, moving on to technological issues, technological role of food colours. So we asked this question right at the start, and hopefully you ought to think about it. These are some of the reasons why colours are added to food. They all impact on the acceptability of products. Yogurts and ice creams are products that naturally like colour. The colour of cherry yogurts probably arises from beetroot extract rather than cherries. Some foods lose colour, as we'll see later in our discussion of green peas and chlorophyll. And it's also important to assure batch uniformity, such as in products like this lasagna, which should look the same as those manufactured last week or last year. If you're interested, see this FST blog for quite a lot of more examples. Moving on. Yeah, maintaining examples. This is a very good example of using science to maintain the colour of a food. If you slice an apple, it goes brown quickly. This is part of the natural decay process of the fruit and is mediated by the enzyme polyphenol oxidase, PPO. PPO can be inhibited by lowering the pH, such as spraying the fruit with lemon juice. This is so effective that even apples don't go brown for a couple of days after opening packages of sliced fruit like this, which extends the shelf life and hopefully encourages more people to eat their 5 a day. Modified atmosphere packaging is also used, so before the package is opened, a range of foods are protected from damage by oxygen, that is to say oxidation, by the use of modified atmosphere packaging. Here oxygen is removed and replaced by carbon dioxide. And there's some examples there. You can pause the video, look at this slide to see some of the examples used very widely these days. Okay, so again, over to you. Artificial colours, what do you think? So stop the video and presentation and have a think about this issue. Okay, I'll assume you're pausing now. Right, so I'll assume you're unpausing, so we'll advance. E-numbers have a bad reputation in some quarters. This is totally unjustified. They are an indication the additive has undergone rigorous food safety testing. Food additives are substances added intentionally to foodstuffs to perform certain technological functions. For example, to colour, to sweeten, or to help preserve food. In the EU and in the UK, all food additives are identified by an E number. Food additives are always included in the ingredient list of foods in which they're used, and there are several categories of food additives that have E numbers. See the links here for more information. The links in the usual places. So you may remember this. Blue Smarties were removed from sale in 2006 when some of the colours previously used were associated with increasing the incidence of hyperactivity in some children. If you want to do more reading on this, read on the Southampton 6 link for more background. In 2008, Blue Smarties returned with a blue colour provided by a dye derived from the cyanobacter spirulina. Though it's called a cyanobacter, it's actually an algae, I think. Yes, I think it's actually an algae. Okay, go back to Southampton 6. These are the Southampton 6 colours. The study found that artificial colours that are sodium benzoate preservative or both in the diets result in increased hyperactivity in 3-year-olds and 8 to 9-year-old children in the general population. Famous study. Now the point about this is that all of these things have now been removed from our diet in the UK. The replacement with spirulina is an interesting issue. It begs some interesting questions. Spirulina is classed as an ingredient and as such does not need safety testing, unlike additives, so it doesn't have an E number. See the link here for more information and a blog on this. The EU was looking at this a while back, and to date no progress has been made on answering these questions, probably because once you start including ingredients, it's a gigantic number of things you have to start doing safety testing on. Okay, we'll move on. Practical issues. Right, this image is taken from a website of a food colour supplier. These are natural food colours. They probably look a bit different on your screen to mine, but they should be consistent across your screen. These are natural food colours. Most of them have an E number, and those that don't have versions of colours that do. Here are some synthetic food colours, and most of these have an E number as well. These are blended food colours, which are mixtures of colours that have E numbers. So, for example, egg yellow contains sodium chloride, tartrazine, and sunset yellow. And here's a comparison. Can you see any general difference between the categories of colour? Pause the video presentation, have a think about this. Okay, I'll assume you'll unpaused and have a think about that. Most people note the natural colours have a narrower range of colours, no blues of course, and are less intensely coloured. These reasons, along with the higher stability of artificial colours, are why they have often been used, particularly in the past. However, consumer demand is encouraging food companies to use more natural colours, though this can be a significant food technology issue, often impacting on shelf life, for example. So see the IFT link for some background reading. And that's all for that. Thanks for listening.